Hi everyone, welcome you all for today's video. Today I am going to do another important experiment that build up a galvanic cell or electrochemical cell, and after that I have to find out the electromotive force or EMF of that particular cell. Okay, here I have so many equipments. Here I have a voltmeter. Here I have a potentiometer, okay. Here I have galvanometer. Here I have a working battery. Here I have U-tube, okay. Here I have copper sulfate solution. Here I have a zinc sulfate solution, and here I have wire connections, and here I have copper and zinc electrodes, okay. Those are the equipments. So in this experiment we are going to learn so many techniques. So you have to stay with me start to end, and please observe very carefully what I am doing. Let's go to the video. Okay, first of all, here I have two beakers. I am going to measure 50 milliliter of our each solutions. Here I have a copper sulfate solution. I will measure 50 milliliters of our copper sulfate solution. Okay, I will add it into a beaker. Okay. I will add another 50 milliliters of zinc sulfate solution. Actually concentration of both compounds or solutions are known. Okay. The solvent level should be somewhat sufficient level, because we have to dip our U-tube into this solution. So I will add another 50 ml. Actually the concentration is known. Okay, now the total volume is 100 ml from both zinc sulfate and copper sulfate solution. Okay. Now my solutions are ready. Before start the experiment, I have to dip these two solutions in a ice bath, okay, because I have to adjust the temperature into 20 degrees, actually 25 degrees. That means normal standard temperature 298 Kelvin. So I will dip in ice bath, and to check the temperature I will use a thermometer. I will dip a thermometer in this solution, as well as I have to check the temperature of my two solutions also. So I will use another thermometer. Okay, that's for copper sulfate solution. Here I have another thermometer for our zinc sulfate solution. Okay, so I have to make sure the temperature is 25 degrees. So I will add ice cubes into this water bath, and that will be the ice bath, and I have to stir very well this solution by using a glass tube or glass rod. And the solutions, these are copper sulfate and zinc sulfate solution. I am going to build up a galvanic cell. So I have to add metal compound. So here I have zinc rod first of all I have to clean this sink rod by using sandpapers, okay, because there are so many oxides. So I will brush the sink rod by using sandpapers and I have to clean it very well. This is our electrode. Actually electrode mean both solution and the metal component, collectively we call electrode. Here sink rod, now oxides are removed. After that I have to rinse it with distilled water. I will show you how to clean it. Actually you know, I brush it very well and I will rinse it with distilled water. So I need any other glassware, because otherwise you can't see what I am doing. Okay, I think you can see here I am rinsing the sink rod by distilled water and I will wipe my rod with some tissues. Okay, now it is dry. If the water particles are there, what will happen? The concentration of the solution will change. I will dip this zinc electrode in the zinc sulfate solution. Okay, at the same time I will clean the copper plate. We do not have a copper rod, so I have copper plate. I will brush it by using sandpaper. I will remove the oxides and after that I will rinse it with distilled water to remove sand part, other impurities including oxides and dust particle, and again I will wipe it with small piece of tissues to dry up and we will insert it into the copper solution. Okay, now the setup is complete. Now to complete the galvanic cell, we have to add a salt bridge. We call that U-tube also. Here we have a salt bridge. Okay, we will show you. However, to this setup we have to use a working battery. Okay, here we have lead accumulator. The voltage we have to measure by using this type of voltmeter. Initially we have to get the voltage reading. This is 2 volt lead accumulator. Now it is somewhat discharged. It has 1.9 volt. The voltage of this working battery is 1.9. To calculate the EMF, our galvanic cell, we have to know the voltage of this lead accumulator. Okay. Now I am going to set up the my circuit. Okay. You have to come and look at very closely how we can set up. Okay. Now you can see the setup. Here we have our zinc sulfate solution with zinc rod. Here we have copper sulfate solution with copper rod. Okay. Now we have to connect our, here we have our potentiometer. Here you can see both, here the terminals are connected. That means the other end of the potentiometer contain the 2 ends. Here we can see 2 ends. So we will rotate here. This is our 2 end of our potentiometer and the total length of this wire is 200 meters. This wire is 100 and this wire is 100, that means both are 200. So here we can see the both terminals. So here we will connect the circuit by using our wire connections. Okay. Okay, here we have this crocodile clip. I will clip it into the positive electrode of our lead accumulator, and I will connect it into the our potentiometer, okay, and one end will come to the galvanometer. Okay, you can see one connected for the positive terminal of lead accumulator, that will goes to end of our potentiometer, and from that connection wire will come to the galvanometer. Okay, from the galvanometer we have to connect it into the, here you can see the positive terminal should connect to the positive terminal of our galvanic cell. Here we can see zinc and here we can see copper. According to electrochemical series, the copper contain higher reduction potential, that means electrode potential, that means it will be reduced, okay, to be positive terminal. The electrode potential should be high. So, you know, in electrochemical cells anode should be negative terminal and oxidation will take place. So, oxidation will take place in zinc. Zinc has lower reduction potential. So, actually zinc will be oxidizing agent, that will be negative. So, copper should be the reducing agent or reducing terminal, that means positive terminal. Okay, I connected that. Okay. Okay, now what should we do? Here I will arrange my setup. Other end of the working battery should connect to the this end, other terminal of the potentiometer. Okay, now our galvanic cell has its negative terminal, it's the zinc rod. So, its zinc rod is oxidizing. Okay. So, now circuit is complete, but now to complete the circuit we have to connect these both electrodes. We have to use this U tubes or salt bridge. I will take out a salt bridge. I will take out a salt bridge, and I have to clean it very well, because it, you know, these salt bridges are stored in saturated potassium chloride solutions. Okay. Okay, you can see. So, before insert this into these tubes, we have to rinse it and we have to wipe it both ends. Okay, and after that we can insert this tube into the galvanic cell. Now galvanic cells are connected by using this salt bridge. You can see both electrodes are connected. Now what we are going to do, we are going to measure the electromotive force of our galvanic cell. Okay. To do that, we connected this jockey. We will keep this jockey in both ends to check whether the circuit is correct. If the circuit is correct, the indicator of this galvanometer should go to both ends. Okay. When I touch one terminal, this terminal, it should go to one end, and when I touch other next terminal, it should go to other end. You can see for this end it will go to left side, and for this end it will goes to right side. That means my connection is correct. Now I am going to touch this setup and I will record the point or distance of the wire when the galvanometer reading is 0. Still it is moving. I am using next wire. Okay, we will see. We should not drag our jockey, because if something happen, if we drag, the resistance of the wire will be changed. Okay, still it is moving. You can see still it is moving, the indicator, still it is moving, but now it is not moving here. I kept, I think you can't see, I will show you here near this point. Here still moving, here it's 0. At this point it is 0. It is this point, galvanometer reading will be 0. Okay, you can see at that time we can get the reading of length. Okay, by using the common equation we can substitute these values and we can find out the EMF of our galvanic cell. Okay, that is the end of this session. So there are so many important things. As soon as possible after completing, we have to disconnect these connections. Why? The battery will discharge lead accumulator. At the same time, we have to remove our salt bridge as soon as possible, and we have to clean it very well by distilled water, and we have to store it in saturated potassium chloride solution, because now the potassium chloride ions inside the salt bridge moves to or diffuse into the solutions. That means the salt bridge is getting unsaturated. So we have to clean it very well by distilled water like this, and we have to wipe it to dry, and after that we have to add it into again into the saturated potassium chloride solution to saturate. Okay. Okay. Now I stored my salt bridge. Okay. After that we have to clean everything. The important things, when we are using this jockey, we should not drag. We should not drag like this, because the diameter of this wire will change. We have to keep it like this, and suddenly we get out, and we have to keep like this. If we drag, the diameter will reduce. Okay, and the same time if we drag, the lead accumulator will be discharged. Because of that we have to little by little we have to keep it like this. Okay, those are the things. If the terminals are not correct, the galvanometer reading will goes to one side only. If the indicator goes one side only, that means our setup is not correct. Those are the important things, and let's meet in another video. Goodbye for you all. Please subscribe my channel.